G'day Year 10s. Look, we're looking at graphing quadratics. Now we've been doing a bit of work over the time of quadratics, and we remember that there are times that a quadratic won't even cross the x-axis. It still will have a turning point, but it has no what we call roots of equations. There's a few ways to find out how to find the turning point. One is a form of the uh, completing the square. I'm not a big fan of that one. One is if we find out the x-intercepts, the turning point is always halfway between. So if we can find the distance between the two x-intercepts and divide it by 2, that gives us our x value, and then we can substitute that in to find the y value. That's one of my preferred methods of finding the turning point. Another way of finding the turning point is using the value of negative b over 2a. That'll give you the x value of the turning point. And of course, there is a completing the square so that if it's in a certain format, it is quite easy to do. I'm not really going to make you use that format, but just to show you what it looks like, y equals a outside of x minus h squared plus k. And if it's in that form, then the turning point, you actually have the full turning point being h and k giving you the value. The other thing that we're going to be talking about is something called the axis of symmetry. The axis of symmetry. In other words, is simply, it's where does it cut in half. So whenever you have the turning point, the axis of symmetry will be the line that goes through that. So for example, if this was at a value of, say, 3, the axis of symmetry would be x equals 3. That's the equation that goes through 3. Okay, I'm going to just do some questions on it. I don't want, it's fairly much revision, so it shouldn't be too bad for you. So let's have a look at some questions. Okay, this one. Now I'm going to rearrange it so it looks a little bit more familiar to you. It's the difference of 2 squares. You have to remember this. It's beautiful. I love this. I'll change it to 2 squared. Remember, a squared minus b squared equals a plus b times a minus b. And so y will equal 2 plus x times 2 minus x. And that's factorized. So to find the x-intercepts, which is one of the things we're asked to do, the x-intercepts are when y equals 0. So 0 equals 2 plus x. And so I don't need the brackets around the 2 plus x, do I? 2 plus x. So x will equal negative 2. And 2 minus x equals 0. So 2 will equal x. So we have plus 2 and minus 2 are the intercepts. So negative 2, 0. And 2, 0. Another thing we're asked to find is the turning point. Well, the turning point is halfway between those values. The turning point of x would be 2 plus negative 2 all over 2. So the average x value, okay, which in this case ends up as 0. So when x equals 0, what does y equal? Well, y will equal negative 0 squared plus 4. In other words, y equals 4. So y equals 4 when x equals 0. So there's our turning point. Now another thing that we're asked to do is to name the axis of symmetry. Well, the axis of symmetry is always x equals the x value of the turning point. Last thing it says to sketch the graph. Okay, it's a sketch. Remember, don't get too hung up. Goes to 2, negative 2, so negative 2, 2, and the turning point is 0, 4. It's a parabola. The other thing I want you to always know is one thing that I learned and I always remember, when you have a negative value in front of the x squared, That means it's a sad graph. Whoops. That tells me that I've made a mistake. Can you tell me what the mistake is? I can tell me what this mistake is, and it's handy to know that because now I can say, okay, I did make a mistake because the I didn't plot the correct value here. The turning point was not at -4, it was at +4. So that's where the turning point should be. And it's because I knew that it was a sad graph that made me realize that I had made a mistake. So that's a handy thing. Negative value in front of the x squared makes it a sad graph, unhappy face. Positive, it's a happy graph, would go the other way. Okay, let's look at the next one. We have y equals negative x plus 1 all squared. How do we interpret that? What do we do with that? Well, first thing to do is to say, well, that is in this formation of a completed the square graph. A outside of x minus h squared plus k. So in this case, we end up with y equals negative outside of x minus -1 all squared plus 0. So h equals -1 and k equals 0. So the turning point is -1, 0. That's cool. The axis of symmetry, so the axis of symmetry is simply x equals -1. It always is the x value of the turning point. The last thing that it asks for is to find the x-intercepts. How do we find the x-intercepts? Good question. It's not really. It's easy. The x-intercepts are when y equals 0. So actually I'll change color. When y equals 0, we get the x-intercepts. So 0 equals negative x plus 1 squared. So what would make that true? When would that equal 0? That would equal 0 when x plus 1 equals 0. So x would equal -1. So it only has one x-intercept at x equals -1. So -1, 0. So if I sketch this graph, I'll use blue because I've done a few other colors. We have it touches at -1, 0. So -1 is where it touches. There's the y-axis. There's the x-axis. We have a turning point, which is at -1, 0. It's negative, so it's actually sad. It didn't ask us to find the y-intercepts. If I expanded the brackets, I would find where it crosses there, but I don't need to because it hasn't asked for it. The axis of symmetry is x equals -1, and there's a sketch of that graph. Two more. The next one we're looking at is, again, reflecting on our formula, and so I get y equals x minus -1 squared minus 1. The reason I do that, and you might be wondering, why am I making that minus negative? Well, in the formula it says minus h, so I need to change the plus to a minus negative, so I can go, well, what is h? H must be -1. So my turning point is -1, and k is plus k, so that's plus -1. So that means k is also -1. So my turning point is -1, -1. My axis of symmetry is x equals -1. And the last thing to do is the x-intercepts, if any. So at y equals 0, I end up with 0 equals x plus 1 squared minus 1. I need to expand the brackets. X squared plus 2x plus 1 minus 1. Sorry about cramming it in. I'll take this up the top here. Remember, plus 1 minus 1 cancels, so 0 equals x squared plus 2x. Look for a common factor, x outside of x plus 2. Therefore, x equals 0 and x plus 2 equals 0 and x equals negative 2. So my two x-intercepts are 0, 0 and negative 2, 0. So to sketch my graph, I've got 0, 0, negative 2, 0, and a turning point of negative 1, negative 1. And I see a positive a value, means that it's happy. I'm happy, you're happy, everybody's happy. That's the main thing. So 0, negative 2, negative 1 label. And our axis of symmetry, x equals negative 1. Okay. Lucky last, which is same concept again. We have a minus 3. In our formula, it's plus that. So h equals 4, k equals 3. So my turning point is 4, 3. What else do we need to work out? Well, our axis of symmetry, as soon as we've got our turning point, we know what the axis of symmetry is. It's x equals 4. The other thing we need to find out is our x-intercepts. And the x-intercepts are when y equals 0. And it's interesting, I actually just looked at the solutions in the textbook, and I actually preferred how it did it compared to the way I did. So I'm going back to show you. When we let 0 equal negative 3 outside of x minus 4 squared plus 3, what they've done is they've moved the 3 to the other side, so moving the plus 3 over. So I get negative 3 equals negative 3x minus 4 squared. Divide both sides, or to take that to the other side as divide, I end up with 1 equals x minus 4 squared. So now I'm doing the square root of 1 equals x minus 4, and it's going to be plus or minus. So plus or minus 1 equals x minus 4. So therefore, 1 equals x minus 4, so x would equal 5 when I move that over. And then if I use the negative 1 equals x minus 4, I end up with x equaling 3. So my two x-intercepts are 5, 0 and 3, 0. That was a lot nicer. I like that. So the last thing is to sketch its graph. What color will I use? Let's go black. Let's go black. Okay. 1, 2, 3, 4, 5, 3, x. Oh, that was y up there. That looks more like a y than an x anyhow. X over here. Turning point we worked out as 4, 3. So we've got to go up 3. 4, 3 is the turning point. I'll go a bit higher. 4, 3. And we didn't need to worry about the y-intercept. Didn't ask us. I will use, and pick a different color just because I can. I use yellow. And so I have my quadratic sketched for question 3H. Okay, ladies and gentlemen, enjoy.